A teleprinter is an electromechanical typewriter that can be used to send and receive typed messages from point to point and point to multipoint over various types of communications channels. They were adapted to provide a user interface to early mainframe computers and mini-computers, sending typed data to the computer and printing the response. Some models could also be used to create punched tape for data storage and to read back such tape for local printing or transmission. Teleprinters could use a variety of different communication media. These included a simple pair of wires, dedicated non-switched telephone circuits, switched networks that operated similarly to the public telephone network, and radio and microwave links. A teleprinter attached to a modem could also communicate through standard switched public telephone lines. This latter configuration was often used to connect teleprinters to remote computers, particularly in time-sharing environments. Teleprinters have largely been replaced by fully electronic computer terminals, which usually use a computer monitor instead of a printer. Teleprinters are still widely used in the aviation industry, and variations called telecommunications devices for the deaf are used by the hearing impaired for typed communications over ordinary telephone lines. History. The teleprinter evolved through a series of inventions by a number of engineers, including Royal Earl House, David Edward Hughes, Emil Baudot, Donald Murray, Charles L. Crumb, Edward Kleinschmidt and Frederick G. Creed. Teleprinters were invented in order to send and receive messages without the need for operators trained in the use of Morse code. A system of two teleprinters, with one operator trained to use a typewriter, replaced two trained Morse code operators. The teleprinter system improved message speed and delivery time, making it possible for messages to be flashed across a country with little manual intervention. By 1846, the Morse telegraph service was operational between Washington, D.C., and New York. Royal Earl House patented his printing telegraph that same year. He linked two 28-key piano-style keyboards by wire. Each piano key represented a letter of the alphabet and when pressed caused the corresponding letter to print at the receiving end. A shift key gave each main key two optional values. A 56-character type wheel at the sending end was synchronized to coincide with a similar wheel at the receiving end, if the key corresponding to a particular character was pressed at the home station. It actuated the type wheel at the distant station just as the same character moved into the printing position, in a way similar to the daisy wheel printer. It was thus an example of a synchronous data transmission system. House's equipment could transmit around 40 instantly readable words per minute, but was difficult to manufacture in bulk. The printer could copy and print out up to 2,000 words per hour. This invention was first put in operation and exhibited at the Mechanics' Institute in New York in 1844. Landline teleprinter operations began in 1849 when a circuit was put in service between Philadelphia and New York City. In 1855, David Edward Hughes introduced an improved machine built on the work of Royal Earl House. In less than 2 years, a number of small telegraph companies, including Western Union in early stages of development, united to form one large corporation, Western Union Telegraph Co., appeared to carry on the business of telegraphy on the Hughes system. Emil Baudot designed a system using a 5-unit code in 1874. The Baudot system was adopted in France in 1877, and later extensively in France. The British Post Office adopted the Baudot system for use on a simplex circuit between London and Paris in 1897, and subsequently made considerable use of duplex Baudot systems on their inland telegraph services. During 1901, Baudot's code was modified by Donald Murray, prompted by his development of a typewriter-like keyboard. The Murray system employed an intermediate step, a keyboard perforator, which allowed an operator to punch a paper tape, and a tape transmitter for sending the message from the punched tape. At the receiving end of the line, a printing mechanism would print on a paper tape, and/or a reperforator could be used to make a perforated copy of the message. As there was no longer a direct correlation between the operator's hand movement and the bits transmitted, there was no concern about arranging the code to minimize operator fatigue, and instead Murray designed the code to minimize wear on the machinery, assigning the code combinations with the fewest punched holes to the most frequently used characters. The Murray code also introduced what became known as format effectors, or control characters, the CR and LF codes. A few of Baudot's codes moved to the positions where they have stayed ever since: the null or blank and the del code. Null blank was used as an idle code for when no messages were being sent. In 1902, electrical engineer Frank Pern approached Joy Morton, head of Morton Salt, seeking a sponsor for research into the practicalities of developing a printing telegraph system. Joy Morton needed to determine whether this was worthwhile, and so consulted mechanical engineer Charles L. Crum, who was vice president of the Western Cold Storage Company. Crum was interested in helping Pern, so space was set up in a laboratory in the attic of Western Cold Storage. Frank Pern lost interest in the project after a year and left to get involved in teaching. Crum was prepared to continue Pern's work, and in August 1903 a patent was filed for a type bar page printer. In 1904, Crum filed a patent for a type wheel printing telegraph machine, which was issued in August 1907. In 1906, Charles Crum's son, Howard Crum, joined his father in this work. It was Howard who developed and patented the start-stop synchronizing method for code telegraph systems, which made possible the practical teleprinter. In 1908, a working teleprinter was produced by the Morecambe Company, called the Morecambe Printing Telegraph, which was field-tested with the Alton Railroad. In 1910, the Morecambe Company designed and installed the first commercial teletypewriter system on postal telegraph company lines between Boston and New York City using the Blue Code version of the Morecambe printing telegraph. In 1916, Edward Kleinschmidt filed a patent application for a type bar page printer. In 1919, shortly after the Morecambe Company obtained their patent for a start-stop synchronizing method for code telegraph systems, which made possible the practical teleprinter, Kleinschmidt filed an application titled Method of an Apparatus for Operating Printing Telegraphs, which included an improved start-stop method. The basic start-stop procedure, however, is much older than the Kleinschmidt and Morecambe inventions. It was already proposed by Darlincourt in 1870. Instead of wasting time and money in patent disputes on the start-stop method, Kleinschmidt and the Morecambe Company decided to merge and form the Morecambe-Kleinschmidt Company in 1924. The new company combined the best features of both their machines into a new type wheel printer for which Kleinschmidt, Howard Crum, and Sterling Morton jointly obtained a patent. In 1924, Creed & Company, founded by Frederick G. Creed, entered the teleprinter field with their Model 1P, a page printer, which was soon superseded by the improved Model 2P. In 1925, Creed acquired the patents for Donald Murray's Murray code, a rationalized Baudot code. The Model 3 tape printer, Creed's first combined start-stop machine, was introduced in 1927 for the post office telegram service. This machine printed received messages directly onto gummed paper tape at a rate of 65 words per minute. Creed created his first keyboard perforator, which used compressed air to punch the holes. He also created a reperforator and a printer. This was the origin of the Creed high-speed automatic printing system, which could run at an unprecedented 200 words per minute. His system was adopted by the Daily Mail for daily transmission of the newspaper contents. The Creed Model 7-page printing teleprinter was introduced in 1931 and was used for the inland telex service. It worked at a speed of 50 baud, about 66 words a minute, using a code based on the Murray code. A teletype system was installed in the Federal Aviation Administration Flight Service Station Airway Radio Stations system in 1928, carrying administrative messages, flight information and weather reports. By 1938, the FAA's teletype network, handling weather traffic, extended over 20,000 miles, covering all 48 states except Maine, New Hampshire, and South Dakota. Ways in which teleprinters were used. There were at least 5 major types of teleprinter networks. Exchange systems such as Telex and TWX. These created a real-time circuit between two machines, so that anything typed on one machine appeared at the other end immediately. US and UK systems had actual telephone dials, and prior to 1981 5 US area codes were reserved for teletype use. German systems did dialing via the keyboard. Typed chat was possible, but because billing was by connect time, it was common to prepare messages on paper tape and transmit them without pauses for typing. Leased line and radio teletype networks arranged in point-to-point and or multipoint configurations to support data processing applications for government and industries such as integrating the accounting, billing, management, production, purchasing, sales, shipping and receiving departments within an organization to speed internal communications. Message switching systems. This was an early form of email, done with electromechanical gear. See Telegram, Western Union, Plan 55A. Military organizations had similar but separate systems. See Autodon. Broadcast systems such as weather information distribution and news wires. See Associated Press, National Weather Service, Reuters, and United Press. News was received on receive-only teleprinters, without keyboards or dials. Loop systems, where anything typed on any machine on the loop printed on all the machines. Police departments use such systems to interconnect precincts. Teleprinter Operation. Most teleprinters used the 5-bit baud code. This limited the character set to 32 codes. One had to use a fix shift key to type numbers and special characters. Special versions of teleprinters had fix characters for specific applications, such as weather symbols for weather reports. Print quality was poor by modern standards. The baud code was used asynchronously with start and stop bits. The asynchronous code design was intimately linked with the start-stop electromechanical design of teleprinters. Other codes, such as ASCII, field data and flexowriter, were introduced but never became as popular as baud. Mark and space are terms describing logic levels in teleprinter circuits. The native mode of communication for a teleprinter is a simple series 600 circuit that is interrupted, much as a rotary dial interrupts a telephone signal. The marking condition is when the circuit is closed. The spacing condition is when the circuit is open. Following the start bit, the character is represented by a fixed number of bits, such as 5 bits in a baud code, each either a mark or a space to denote the specific character or machine function. After the character's bits, the sending machine sends one or more stop bits. The stop bits are marking, so as to be distinct from the subsequent start bit. If the sender has nothing more to send, the line simply remains in the marking state until her later space denotes the start of the next character. The time between characters need not be an integral multiple of a bit time, but it must be at least the minimum number of stop bits required by the receiving machine. When the line is broken, the continuous spacing causes a receiving teleprinter to cycle continuously, even in the absence of stop bits. It prints nothing because the characters received are all zeros. The baud blank null character. Teleprinter circuits were generally leased from a communications common carrier and consisted of twisted pair copper wires through ordinary telephone cables that extended from the teleprinter located at the customer location to the common carrier central office. These teleprinter circuits were connected to switching equipment at the central office for telex and TWX service. Private line teleprinter circuits were not directly connected to switching equipment. Instead, these private line circuits were connected to network hubs and repeaters configured to provide point-to-point or point-to-multipoint service. More than two teleprinters could be connected to the same wire circuit by means of a current loop. Earlier teleprinters had 3 rows of keys and only supported uppercase letters. They used the 5-bit baud code and generally worked at 60 to 100 words per minute. Later teleprinters, specifically the Teletype Model 33, use ASCII code, an innovation that came into widespread use in the 1960s as computers became more widely available. Speed, intended to be roughly comparable to words per minute, is the standard term introduced by Western Union for a mechanical teleprinter data transmission rate using the 5-bit baud code that was popular in the 1940s and for several decades thereafter. Such a machine would send 1 start bit, 5 data bits, and 1.42 stop bits. This unusual stop bit time is actually a rest period to allow the mechanical printing mechanism to synchronize in the event that a garbled signal is received. This is true especially on high-frequency radio circuits where selective fading is present. Selective fading causes the mark signal amplitude to be randomly different from the space signal amplitude. Selective fading, or Rayleigh fading, can cause 2 carriers to randomly and independently fade to different depths. Since modern computer equipment cannot easily generate 1.42 bits for the stop period, common practice is to either approximate this with 1.5 bits, or to send 2.0 bits while accepting 1.0 bits receiving. For example, a 60-speed machine is geared at 45.5 baud, a 66-speed machine is geared at 50.0 baud, a 75-speed machine is geared at 56.9 baud, a 100-speed machine is geared at 74.2 baud, and a 133-speed machine is geared at 100.0 baud. Federal Communications Commission restrictions to only 60-speed from 1953 to 1972. Telex, news agency wires and similar services commonly use 66-speed services. There was some migration to 75 and 100 speed as more reliable devices were introduced. However, the limitations of HF transmission, such as excessive error rates due to multipath distortion and the nature of ionospheric propagation, kept many users at 60 and 66 speed. Most teletype audio recordings in existence today are of teleprinters operating at 60 words per minute, and mostly of the Teletype Model 15. Another measure of the speed of a teletype machine was in total operations per minute. For example, 60 speed was usually 368 OPM, 66 speed was 404 OPM, 75 speed was 460 OPM, and 100 speed was 600 OPM. Western Union telexes were usually set at 390 OPM, with 7.0 total bits instead of the customary 7.42 bits. Both wire service and private teleprinters had bells to signal important incoming messages and could ring 24/7 while the power was turned on. For example, ringing 4 bells on UPI wire service machines meant an urgent message, 5 bells was a bulletin, and 10 bells was a flash. Used only for very important news, such as the assassination of John F. Kennedy. The teleprinter circuit was often linked to a 5-bit paper tape punch and reader, allowing messages received to be resent on another circuit. Complex military and commercial communications networks were built using this technology. Message centers had rows of teleprinters and large racks for paper tapes awaiting transmission. Skilled operators could read the priority code from the whole pattern and might even feed a flash priority tape into a reader while it was still coming out of the punch. Routine traffic often had to wait hours for relay. Many teleprinters had built-in paper tape readers and punchers, allowing messages to be saved in machine-readable form and edited offline. Communication by radio, RTTY, was also common. Amateur radio operators continue to use this mode of communication today. Control characters. A typewriter or electromechanical printer can print characters on paper, and execute operations such as move the carriage back to the left margin of the same line, advance to the same column of the next line, and so on. Commands to control non-printing operations were transmitted in exactly the same way as printable characters by sending control characters with defined functions to teleprinters. In modern computing and communications, a few control characters, such as carriage return and line feed, have retained their original functions, but many others are no longer required and are used for other purposes. Here is key. Some teleprinters had a here is key, which transmitted a fixed sequence 20 or 22 characters, programmable by breaking tabs off a drum. This sequence could also be transmitted automatically upon receipt of an ENQ signal, if enabled.